Hello everyone, you are all welcome to lecture number 967, and today's topic is some important points about SBR rubber, and why I have selected some summary, or I have summarized all those things so that students can remember in a very simple way. So I have given point wise in a very simplest way. As I have already discussed about SBR rubber means this rubber is manufactured by the combination of bulk polymerization or immersion polymerization of butadiene and styrene, and they join together either in 1, 2 or 3, 4 position, and this we call it bulk polymerization. Bulk polymerization means where the molecular mass is ranging from 1000 to 2000, and in this bulk polymerization it is in liquid state. That's why it is called liquid phase bulk polymerization rubber, or it is in gaseous phase, then it is called gaseous phase bulk polymerization rubber. And here some 2-3 things are very important in this SBR rubber. First is that sodium we are using as a catalyst, and if sodium is not uniformly distributed along with butadiene monomer, then the proper polymerization and the quality of the rubber will be poor, and it will not be of good quality. That's why we have to check whether there is proper uniformly sodium is distributed or not. Secondly, the temperature control, or to maintain the temperature, is also another very important factor, because during this reaction some heat is evolved, vaporization will take place, and if temperature is not controlled, then it will affect in bulk polymerization as well as in productivity. So all these factors are very important, and also, as I have already told you, that once polymerization is taking place, and if it is long chain, several branches, then the elasticity of the rubber will be reduced. It will not be more elastic. So these are very, very important factors for the manufacture of the SBR rubber, and these points I am going to discuss one by one. So this segment what I am discussing is for undergraduate and postgraduate industrial chemistry students, and I have made it in a very simple way so that they can understand about the bulk polymerization of SBR rubber and their impact on butadiene, styrene, the sodium catalyst and branch. So all these things I have already told you, and again I am going to explain one by one. So number one is that is polymerization of butadiene is carried out by bulk polymerization. So it comes under bulk polymerization of rubber, and that is SBR manufacture in the liquid phase. That is called liquid phase rubber. There are 2 phases possible. One is liquid phase, and another one is gaseous phase. So the liquid phase is known as liquid phase rubber, and the gaseous phase is known as gaseous phase rubber. Both processes are carried out batchwise in steel autoclaves designed to operate at a pressure of 9 to 10 atmosphere. So here pressure as well as control of temperature and catalyst sodium, they play very important role in the manufacture of SBR rubber. So always the pressure must be maintained between 9 to 10 atmosphere, and the temperature should not exceed between 30 to 40 degree, or very ideally between 30 to 35, like that. If temperature is exceeding, is serious issue, and it will affect the productivity of the rubber, SBR rubber. And the reason is that during the reaction of polymerization, it also liberates the heat. So in combination, there will be hindrance in production of SBR rubber. And sodium metal is used as catalyst, and so the product is known as a sodium butadiene rubber. In some books and references, they are also called as sodium butadiene rubber. Means sodium is uniformly distributed in butadiene molecule, and that's why it is called, because sodium is used as a catalyst. It works as a catalyst, and that's why it is called sodium butadiene rubber. And if sodium is not uniformly distributed, again there will be problem of quality of rubber, of its elasticity and also toughness. Number 2, in bulk polymerization, a polymer is having 80,000 to 200 molecular weight is formed by the joining of butadiene molecule in 1, 2 to 3, 4 positions, and that I have given here. This is your butadiene molecule, that is 2N means maybe 80,000 or 200,000, N stands for that, and here it is 1, 2, 3, 4, and the one double bond is at 1 and the other one is at 4. So it is either at 1, 2 there will be polymerization, or at 3, 4. So these two positions are there, and after the polymerization, bulk polymerization, you will get in bracket this one. So here it is going from 1, 2, 3, 4, and then from this side 1, 2, again 3 and 4. So here it is 3, 4, and here it is 1, 2 position polymerization. So in that chain polymerization is given SBR rubber 1, 2 and 3, 4 joining positions is shown here. Number 3, the highly branched structure of sodium butadiene rubber. For example, the presence of very large number of side vinyl group. So if there are large number of side vinyl group as a side chain branch, will decrease its elasticity and of course its toughness. So the large number of side vinyl groups have negative effect on its elasticity and also other properties like hardness. So point number 4, that is the rate of polymerization and the properties of the rubber depends upon the following factors. They are given one by one. Roman 1, uniform distribution of sodium in butadiene. I have already told you that if sodium catalyst is not uniformly distributed in that is sodium rubber, the butadiene rubber or SBR rubber, then the quality of the rubber will not be good. Second point, that is interface contact or area between them and the purity of monomer. So actually the purity of the monomer also a very important factor. If your monomer like butadiene or styrene, if they are impure, again there will be serious issue. So before manufacturing, we have to check the purity of the monomers. They play a very important role because you know that it is a free radical reaction mechanism, and in that free radical reaction mechanism, the monomer that is butadiene and styrene and the free radicals, they coexist and they polymerize. So if in case the starting material monomer is impure, the free radical interaction, coexistence with them will not be smooth. That's why the purity of the monomer is very important. So the purity of monomer. The third one is the control of temperature and pressure. That is also, I have already told you, that is very important factor. If temperature and pressure is not controlled, we cannot expect the product, because it also generates heat in the reaction. Number 5, strict control of temperature is necessary, because after primary active centers are formed, polymerization proceeds with the liberation of heat. After completion of polymerization, the unreacted monomer and other components are evaporated from the autoclave. Then nitrogen is fed to the autoclave and the rubber is discharged. Number 6, that is immersion polymerization process. I have already told you that the latest one is, that is immersion polymerization, where soap we are using as a emulsifying agent. Is continuous high capacity process. It is high capacity process means we can manufacture in large quantity. Process which provides a large output of the synthetic rubber with uniform properties. The process can easily be controlled. Local overheating can be avoided, and copolymerization of the 2 or more monomers is also possible in this process. And number 7, isoprene and butadiene styrene rubbers are mostly extensively used rubbers for making tires and other wares. The sorts of butadiene styrene rubbers differ both in the conditions of polymerization and in the ratio of monomers in the initial hydrocarbon mixture. So with this I will stop, and in next lecture again I am going to continue these important points. And if you can remember, I mean the students can remember these important points which are given in the form of summary or abstract, then they can understand the whole process of manufacture of SBR rubber, and in general the properties and its physical, chemical nature all will be very clear. So that's why I have made it in a very simple point wise to understand this SBR rubber, that is butadiene styrene rubber. Once again, thank you very much for watching the lecture.